Have you ever wondered what happens when a cable inside a wall overheats? Well, we're going to find out. This is a pretty standard inside wall. Some vertical 2x4s, drywall on the back, and drywall in the front. Well, I cheated. I put some plastic so we could see what's happening, but I did want to have something in front to keep the airflow inside the wall pretty much the same as in a real wall. And over here is a piece of standard 14-2 cable. And what we're going to do is pass an ever-increasing current through it until it starts to smell and smoke and bubble. And, well, we're going to find out exactly what it does. And to be able to do that, I have an AC arc welder set up with a variac so I can very precisely control the current going through the wire, and that will exactly mimic the heating you would get with a piece of household wiring that is attached to a bunch of plugs that somebody has, well, maybe plugged in too many heaters. Now, you might ask, how realistic is that? You would hope your fuse or your circuit breaker would trip or blow and prevent anything bad from happening, but sadly, people sometimes change fuses to bigger ones that are way too big for the circuit, and circuit breakers have been known to fail and not trip when they should. So what we'd like to do is see what the margin of safety is between the rated current, 15 amps, and the current at which, well, bad things happen. So we're going to try and test that. Now, I also have a nice new little toy, and that is this Seek thermal camera, and we're going to use that to see if we can see the wire heating up and if there are any hot spots, such as perhaps inside the 2x4s, that might make the situation even worse. So, with all of that having been said, let's get on with the experiment and see what happens. So, like all of these tests, we'll start by just bringing up the current to 15 amps, the rated current for 14-2 wire, and we'll let it sit that way for 15 to 20 minutes, and then what we'll do is we'll look at it with the thermal camera and see if we can notice any heating at all. So, see you in 15 minutes. All right, so we're about 15 to 20 minutes into it, and I've been playing around with my nifty little IR camera, and if I look at the very end of the cable, we can see the MAR connector at the very end of it, and the cable is pretty much marked by the white line corresponding to 39 or 40 degrees Celsius. The MAR connector is only red, so it's just a little bit less, and the surroundings are around 28 Celsius, and it is a warm day outside, so that's not surprising. Now, the unfortunate thing is, if I move the IR camera around, it turns out, as I was afraid of, the plastic sheeting pretty much completely blocks the IR. So what that means is we can't look at the main part of the wire, but we can see the end, and probably the temperature along the rest of the wire will be pretty much the same. Now, the neat thing is, because of the slightly larger white area up top, that's where the wire is going through the hole in the 2x4, and we can see it's certainly a slightly warmer but not greatly warmer area than the rest of the wire. So that's 15 amps. Now I'm going to set the current up to 30 amps, and once again I will see you in about 15 to 20 minutes. Some interesting results with the thermal camera. If I put it around behind the plastic, what you can see is the peak temperatures of the cable are now somewhere in the mid 60s degrees Celsius, and clearly warm around where it goes through the 2x4 right in the center, and the MAR connector is once again pretty cool, or relatively cool, compared to the rest of the wire. However, if we go around to the other side where I've hooked up the welder, we can actually see the temperature difference between 12.2 and 14.2. So what I did was I used some 12.2 to connect the 14.2 to the welder terminals, and the reason I did that was because I'd noticed before, if I have the welder terminals hanging off the 14.2, tends to pull the wires apart, producing extra stress on the already too hot insulation, producing maybe an unrealistic premature end to the test. By using a short length of 12.2, I'm hopefully relieving any stress here, and inadvertently it gave us a chance to look at the temperature difference between 12.2 and 14.2 for the same current, in this case 30 amps, which, well, exceeds the ratings of both of them. And of course what you can see is that the 12.2 is a little bit cooler than the 14.2, and we would expect that. And I'm not entirely sure why the 14.2 is a bit cooler on this side, but it might simply be because of the wind blowing in the yard that's, well, cooling it off just a little bit. So now what we'll do is increase the current to 40 amps and once again leave it for a few minutes. The interesting thing that the IR camera has allowed me to do is get a sense of what the time constant is for the wire in this situation, and the thermal time constant seems to be around 15 minutes. If I look at the temperature on the wire, it's somewhere around 90 Celsius, and that's significant because 90 Celsius is what the wire is rated at, and it's also now quite visible through the plastic in front of the wall, although of course the temperature readings we're getting are, well, quite off. Now, one thing this does do is it explains why in previous tests when we went from 40 to 50 amps bad things happened, because quite clearly at 40 amps we're very close to the boundary of the wire being too hot to last any significant time. So I think what we'll do at this time is increase the current to 45 amps and see if anything bad happens. And if nothing bad happens, then we'll try 50, and I'm pretty sure something bad will happen. So 15 minutes later at 45 amps, and the wire is surviving. The temperature, as I see on the IR camera, is somewhere between 90 and 100 Celsius. I think at its peak it's actually around 100. Actually now it's reading 105, 107, 108. And the wire is doing admirably well. That's probably not too surprising, because if they rated it at 90, they certainly wanted to have a few more extra degrees. So again, there is a bit of a margin of error for safety there too. Now, the interesting thing is, on the other side, over there, the temperature is about 5 to 10 degrees lower. And I was initially thinking it was because of the wind that's blowing, but I also think it's because of these pigtails that are probably helping to draw away some of the heat, to dissipate the heat and cool the 14.2. So I think what we're going to do is now raise it to 50 amps and once again see what happens. At 15 minutes of 50 amps, here's what we see at the end of the wire. So the maximum temperature is somewhere around 125 Celsius. To put things in perspective, for people who prefer Fahrenheit, 100 Celsius is when water boils. So we're now above the boiling point of water. The area around the hole in the 2x4 is considerably hotter than the surroundings. Not surprising. You can even see the drywall near the wire is quite hot, and the MAR connector or wire nut is also fairly hot, but not as hot as the wire. So all in all, that's quite impressive. I can smell that nice hot plastic smell, and if I feel it, well, it's certainly too hot to touch, but the plastic is certainly quite flexible and spongy, so we are very close to the limit of bad things happening. Let's look at the other side over there. So the maximum temperature is probably around 115 C or so. And again, as we would expect, the 14.2 on top is the hottest, and the 12.2 that sort of snakes around the bottom and exits on the bottom right is quite a bit cooler. So I think what we're going to do now is further increase the current, maybe to 55 amps. So at about 5 minutes of 55 amps, I don't know how well you can see it, but the wire is visibly deforming here and well, and over there. It's beginning to bulge somewhat. I'm guessing gases are forming inside. Oh, and in the other side, it's even more apparent. You can see some bulges occurring there, and I think the main reason we've not had any shorting is because I've made sure that there's very little stress on the wire. So what do we have? It looks like we're at about 100 and, well, peaking at 147 was the highest that I saw. Oh, 155. So we're somewhere around 155, even 160 Celsius, where the plastic on the wire is now really beginning to break down, and a short is probably quite imminent. Interestingly, where I'm looking at it at the very end here, there is no visible sign of, well, there's a little bit of deformation of the plastic cladding, but not too much. Oh, and now you can see parts of the wire are now really going bad. It's clearly beginning to char inside. I would have expected smoke to be given off, but so far not much of that. And to put things in perspective, the total power being dissipated in the wires is probably around 160 watts at this current, and in each section here it's probably close to 50 watts. Well, maybe even more than that. Probably closer to 60 or 70 watts. And that is an incredible amount of heat in a relatively small surface area, so it's no wonder the temperatures are pretty high. Let's measure the temperature at the edge again. Well, that's sort of funny. It's jumping all over the place. Oh, I know what's happening. It's cooling down at the end now because a short has developed somewhere inside. In other words, between the source of the power and the end of the wire over here. So the end is cooling down now. So just based on what I'm seeing here and looking at the voltage, which has stayed pretty much the same at about 2.5 volts at 55 amps, my guess is the short has occurred right in this 2x4 here, because the state of the wire over here is now pretty bad. The state of the wire over here is pretty good. So maybe, as we might have suspected, the 2x4 is probably the place where the wire gets hottest because it's harder for the heat to escape. So here's something for you. This is the back side of the wall. On the left you can see the end of the wire. On the right you can see where the current is being fed into the wire, and on the bottom you can see the warmth of the wire coming through the drywall, and that's showing up as about 40 degrees, so 10 degrees Celsius or 20 Fahrenheit higher than the ambient. What does it look like from the front? Interestingly, it looks a lot like the drywall, so the thin clear plastic sheets are behaving pretty much the same as the drywall in terms of blocking the direct infrared radiation from the wires, but are getting warm like the drywall and emitting their own radiation, and just like the drywall, are about 10 degrees Celsius higher than the ambient temperature. So, you know, if we used one of these things inside a room and looked at a real wall, if we saw temperatures like that, we'd know something bad is happening. Now, I'm actually quite surprised that we aren't seeing these cavities fill with any sort of smoke. So I think, once again, we'll up the current, this time to 60 amps. So 4 times the rated current of this wire. And, well, let's see what happens. Oh, and the interesting thing is, now over here, we're getting some smoke from the MAR connector. So I think what's happened is whatever short we had in here has maybe unshorted itself, and this is heating up again. So the end of the cable is certainly beginning to burn now. The plastic is charring. It certainly smells, and there's smoke coming off it. Really quite interesting that the suspected short in here unshorted itself, and my guess is maybe the copper started to oxidize a bit, and even if it was just a thin oxide layer, because the voltages are so low, it wouldn't really make a huge difference whether it was a poor insulator or a good insulator to channel all the current back around the end. We're getting quite a bit of smoke now from the wire in here. Oh, and look, the MAR connector has completely come apart now, and the end is going to drop off. That's very interesting. That's the first major failure I've seen of a MAR connector, so maybe I didn't twist the wires very well. Certainly the plastic, at whatever temperature this is, has liquidified. I guess that's liquefied. Oh, so look at those temperatures now. 220 Celsius. So, yeah, things are going bad very quickly. Now the hottest temperature is around the MAR connector, or I should say where the MAR connector used to be. So in Fahrenheit, that's probably somewhere around 400 Fahrenheit. We're getting close to the temperature that solder would melt. Quite a bit of smoke now in here and sort of leaking out. What do we have in the back? Oh yeah, look at that. Once again, we can sure see the effects of the temperature. In fact, it looks like over here we're at what? 35, 36 Celsius max, so 15 degrees Celsius or 30 Fahrenheit above the ambient. What about our input over on the side? Look at those temperatures, 195, 197. So pretty much, once again, 10 degrees Celsius lower. Oh, and lots of smoke around the front. So I don't know how visible it is with the camera, but these cavities are now filling up with the vile plastic smoke. Not surprising, that's what I was expecting. What's going to be interesting is to see is whether this catches fire or the lack of oxygen prevents it. The wire certainly is charring. Oh, and I can even feel the heat on the plastic here quite a bit, so it's no wonder the camera is picking it up. And, well, the end here is doing a little bit better, but I'm actually beginning to think maybe the short has reoccurred in the middle here. This side now has much more smoke in it. In fact, I'm beginning to wonder if our short has moved over here. No, yeah, it might have, because our voltage has dropped a little bit. So it's very likely that the short has occurred somewhere in the middle here. I can see some smoke coming from this side of the wire. Not so much here, so I'll bet you the short's around here now. And just looking at it from the outside, it looks like halfway through the left panel, there's quite a bit more heat on the left side. So I'm not sure if that means the short has now moved to the center of that panel or not. And once again, let's look at the end. How is that looking? Oh, that's cooled down a lot from 200 Celsius. It's now around 100. So yeah, a short has occurred somewhere between it and the other side of our wall. What's the back looking like? Can we make heads or tails or where the short is from that? No, not really. Although it does look like there's a bit more heat on the, in this case, the right side where the power is coming from. How are things at the power input? Once again, we can see our MAR connectors top right and the 14.2 going through the 2x4s top left. And we're certainly at 220 Celsius peak or so, so not surprising. I'm going to move away from here because I'm getting smoked out. Well, I think we'll make it a bit more exciting, and I'm going to raise the current to 70 amps, and let's see what happens. This would, of course, be many things going wrong and highly unlikely, but it is very interesting to see what happens. Our voltmeter switched off. I'll switch it back on. So little over 3 volts being dropped along the wire. So we're at over 200 watts now being dissipated in the system. Much more smoke over here, much less over there. So I think the short is now over here. Just look at how that cavity is filled with smoke. And it's of course leaking out the holes in the plastic. You can imagine any cracks where the drywall attaches to the 2x4s. It might be leaking out there. And you could sort of imagine that if there were any spark, this might instantly catch fire. We've got a lot of smoke even leaking out around here where the 2x4, where the hole in the 2x4 is the entry point for our, well, what is left of the 14.2 wire. Look at this. So the smoke in our left wall segment is clearly carrying heat up the wall. I'm guessing it's brought the temperature up to about 45 Celsius. This is almost confirming now that the short has occurred either in the 2x4 in the middle or a bit to the left of it. Let's look at our cables. $236 I saw. 250. So yeah, really quite hot. We must be close to the flash point or the ignition point of the smoke. You would certainly hope by now that your smoke detectors are going off in the house and you can evacuate or turn off the power or whatever you decide to do. We'll just leave it this way a bit. Oh boy, that smoke's bad. Let's see what happens on the other side of the wall if we can see that heat through the drywall. Oh, and we can. Not nearly as apparent as through the thin plastic. I guess that's not surprising, but it's certainly hotter on the side with all the smoke in it, and we can also see there's a lot of heat around the cable. Well, once again, let's up the current, see if my new Variac can spit out 80 amps. Seems to be able to. So 80 amps and about 4 volts. 80 amps and about 4 volts. So 320 watts, probably all being dissipated in here. I would think, yeah, even our number 12 now is getting not too happy. look over here where the wire goes in. You can see some glowing. So we're really at the close to the point of ignition now. Oh, and there's a fire. Oh, and there's a fire inside too. Not at all surprising with this sort of situation. And you can see how the smoke has sort of turned to black now. You can also see a bit of green on the flame near the copper wire. And what does this look like with the IR camera? Well, we're now getting around 90 Celsius as the maximum temperature as we look through the plastic. What does it look like on the drywall side? Drywall's doing a pretty good job of shielding the heat. It's only about 40 Celsius coming through, and no visible sign of problems on the drywall on this side in spite of the fire. So now our current's gone to 0, so somewhere the wire has broken. I don't really know where, but that's the end of our fire. So there you have it, a extreme overcurrent test for a standard 14-2 wire in a standard North American wall. It was quite interesting to see how it took quite a while before it actually caught fire. And when it did, I think the oxygen-starved nature of the enclosed wall cavity actually did reduce the amount of flames. It was quite interesting to be able to see the temperatures of the walls on the outside to some extent showing that there was a too hot wire on the inside, even though the temperature we saw on the outside of the drywall was considerably less than the temperature of the wire. I would say if you can see much sign of a warm wire through the drywall, well, you should do some investigating. The good thing is that for anywhere close to normal currents, we do have a significant safety margin in what the wire can handle. But at the same time, of course, you can imagine with all the testing that the manufacturers and the safety agencies have done, there's a very good reason that these wires have been rated at 15 amps so that you can have multiple things go wrong, or the wire being situated in an extremely hot environment like an attic and still be safe. So once again, anybody using wires like these really should make sure that they only get used to the maximum rated currents, and if it's continuous use, probably about 25% less than that. In fact, I believe that's what the code requires. So there you have it, another test. I'm going to do one more test with this wall at least, and that is I'm going to try some of the pink extruded foam insulation, the rigid stuff that is very common. There's also the blue stuff. I suspect they're pretty much the same. One is made by one manufacturer and another is made by another manufacturer. That should be quite interesting because somebody did point out that they are quite a bit more flammable than the spray foam. So we'll do that test next time. Until then, thanks for watching. See you soon.